So if you work with testing, then you're probably interested to know what I mean by everything and how you would test it. How many people have tested everything at some point in their life? No? Never? Okay, then you're probably curious what I'm talking about. Often when people talk about how much you can test, they put some sign like infinity on. So let's, for example, say that we have a small application with one button, you press it once, and that's your test. Then you could devise a test that you press it twice, and you can have a test it 3 times, etc. And if you're an annoying person like that, you will have a test that goes on for infinity, clicking the button infinite amount of times. Usually that's not something that people actually try to do. Usually people just try to count something like combinations. You have different input fields, or you have different paths through your code or something like that. And then you count all the permutation of combinations or everything, and it doesn't matter what kind of application you have, you always end up with something that has something to do with the universe. It's either similar to the size of the universe in amount of stars, or it would take the age of the universe, or something like that. It's astronomical figures. Does that sound familiar to you? Somebody? Anybody? No? You can't test everything. That's what people often say. Because you have these huge amount of combinations of stuff. Even with the one application with only one button, you can test it to click on it that many times. I really hate that saying. How many people hate that saying? Haven't even heard of it? I really hate it because this often becomes an excuse for testing very, very, very little, or almost nothing at all. What people usually do is they try to find some sort of scope within all of these enormous amount of possibilities. And even if you've never heard about something like equivalence partitioning or something like that, you probably do that, because when you test something like an input box or something, you would say that I probably just try to type a name here, and then you try to put in all the different special characters and the Swedish characters, and then you say, I have tested all of the relevant combinations. Of course, you haven't tested all the combinations of every letter. You just say that they are equivalent to each other. And in that way, people try to carve out some sort of test scope within this gigantic astronomical universe of everything you could possibly test. So when I say I want to test everything, I'm not really referring to an infinite amount of clicks or even all the different combinations that are possible, which are usually astronomical. I'm just talking about I want to test everything that I want to test. Because usually what happens after people have set some sort of test scope, they get project restraints, how much time you actually get to do it, or how many people you have, and it's often very, very tiny. And inside this bubble, a lot of people live, and they never want to go outside the bubble because, you can't test everything. So why even try? I don't want to do it. I just want to be within the project constraints. I will just click a little bit here, and then I'm done. Now, there's a specific reason why I went outside this bubble. I work for this company called Axis. Axis invented network-connected surveillance cameras. It's the largest company in the world when it comes to surveillance cameras that are connected to a network, and we've been doing it for 20 years. So we really know how to test a surveillance camera. We really know that. And we've been experimenting with this for 20 years, and not a problem. So we lived inside this bubble, and no worries. And then something interesting happened. Axis wanted to do one of these. This is a door controller, which you connect to things like this. So all of these input-outputs are to connect to the different things, to have something in your office. And in our offices at Axis, I go blip, and then I do my PIN code, and then I can go through the door. So Axis wanted to do this kind of device and connect it to the network. Because most of the door controllers and stuff in a building like this, it's all analog technology from the 80s. It's really incredible, but they do that because they have no incentive to move forward, just like the music industry had no interest in streaming video, streaming music or something like that. So there's a lot of analog stuff. So Axis wanted to try to do the same thing as with the camera surveillance industry, put a network on it so you can control it over the network, Internet of Things kind of thing. We've been doing that for 20 years. The only problem was that we knew how to test surveillance cameras, and we had evolved over 20 years, different kind of test cases, how to test them, always improving that. We had no idea how to test one of these things. So we usually do these kind of embedded devices. The cameras are just basically Linux servers, and this is a small computer, a Linux server, that controls a door and lock and stuff like that. And we had no experience in how to test this. And of course, there are some basic things you can do. If you're a tester, you will start thinking, okay, of course, I want to take my card, and I want to blip, and I want to put the wrong code, and the door should be locked. And people start to list all these kind of things, what you would like to test. The bad guy shouldn't be able to get in with a card that's not valid, and I should not be able to get into the office in the weekend, or something like that. Different rules, different changes. And people sit down and try to create some sort of test cases or something. If you're lucky, you will get some requirements. Do people usually get requirements? No, we don't do requirements at either at Axis. We had a talk here at Foo Café about that as well. So we were there figuring out what are we going to test? What are the different test cases we want to do? Okay, it's not that difficult. There are some access action. Well, I'll call it access action. The things you can do in this kind of system where there's this device that is controlling the door and stuff like that. There's usually one of these on the outside and another on the inside, and you have a lock. It's pretty straightforward. It's not rocket science. You can swipe a card, and that's 4 different ones, because there you can have a valid card, and you can have an invalid card, and you can be on the inside, and you can be on the outside. And then you can enter a pin, the blip, 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 and you can have a valid pin, an invalid pin, inside and outside. And you can, of course, open the door, and by opening the door, I also mean closing the door. Open and close the door. Or you could just do nothing, like wait. So then you can start thinking about all the different scenarios you have. You have something like, oh, maybe I'm going to the office and I swipe my card, and then my colleague comes, hi, I talk to him, and then I would be doing nothing. That kind of stuff. So it's not that much. It's just a total of 10 actions. Of course, there's a lot of other stuff you can test on this device, because it has the rules for when the office is open and closed, and it has the different kind of people in the database. There's a huge amount of different kind of features, but this is just the access actions. There's just 10 access actions. And of course, what happens with this whole astronomical thing is that when you start to combine them in different combinations, you soon get a huge amount of different things you can do. And I was really worried that we had no experience in testing this. We didn't know really what we were doing. And the single most important thing that the CEO of Axis said to the project was, whatever you do, don't ruin the good reputation of Axis, because we're known for the quality of the cameras and we do so great stuff. So if you do a terrible product, it will be bad for the brand. Okay? So no pressure. And we didn't know how to test it. So this was my nightmare scenario. There's some important customer, Wall Street or something, and because of some sort of strange combination, people can't get into the office. Imagine if some big customer does this and they can't get in. Or even it's Friday afternoon and you can't get out of the office because the whole system has collapsed because of some bug that we missed. So I really wanted to try to just test everything. We'll just test everything. How difficult can it be? It can't be possibly that be hard. Okay, so the access action, 10 different ones. if we just imagine a sequence of 5. So, for example, I swipe my card, I enter the PIN, I open the door, and then somebody swipes a card after me and enters a PIN. That's 5 different actions. So we create these sequences of 5. So it might be something like that. We'll just start with, let's say A is the swiping of the card. And I would like to test the swiping of the card 5 times. Of course, I would like to test the swiping of the card 1,000,000 times. I asked the developer how many times he had tested it. Did somebody want to guess how many times he had tested it? Once, yeah. He didn't even understand the question. If I asked him how many times had he tested, he was, what? Don't understand the question. But just for the combinations, let's imagine that one of the combinations I want to test is swiping the card 1, 2, 3, 4, 5 times. Just doing that. And then I might want to test another combination would be swiping the card 4 times and then entering the PIN on the 5th time. And we'll go on and on like this, creating different kinds of combinations. And of course, there's a lot more than just A and B. You could swipe a card and on the outside and the inside, and a PIN on the outside, the PIN on the inside, etc., etc. There's a lot of different combinations. So if just for these 10 different actions, a sequence of 5, how many? Anybody want to guess how many it is? It's not that many, really. Nobody want to guess? 100,000 different sequences. So combining 5 different actions in all 10 different actions in a sequence of 5 in all different combinations, it's 100,000. So it's not really that galactical. It's not age of the universe or anything like that. It's pretty small. So I was thinking this should be a reasonable scope. Of course, this is just the sequences, so the total amount of actions is 500,000. Because each sequence is 5 actions long. So 500,000 actions. And now I was thinking, I really need to get some student to do this. I don't want to do this myself. It's going to take 700 hours at least. So one person working 7 hours a day took 100 working days to get this done. And then it comes to project restraints, of course. No, it sounds unreasonable. Let's not do this. Let's do something else. But of course, maybe if we automate it, it might be possible to do it anyway. Well, is it worth it? People are stuck in the bubble of you can't test everything, so if it doesn't seem reasonable, let's not do it. I was really worried about this. What is the risk if we don't do this? We're hoping to sell a lot of these. Axis sells probably over 1 million cameras a year. I think it's probably more closer to 1 million per quarter or something. It's a huge amount. We weren't expecting that for the door controllers, but at least we were expecting to sell several thousands of this a year at the very least, and in the future even more. And people are always going in and out these doors. Like at Axis, the office is there. We have these different buildings, and people are going to meetings. They are going through. Even people that don't go to meetings, they go to lunch and they come back. People are going in and out all the time. So we're expecting several million customer actions a day. So people are not always going to do exactly the use cases that you have tested and thought this is the reasonable thing to do. Because somebody is going to come and he's going to blip his card, and then Eddie, hi Eddie, and then he's going to blip his card again because he forgot that he had already blipped it, or you blip your card, you accidentally do the wrong PIN code, and then you blip your card again. It's bound to happen. So I was pretty sure that it's only a matter of time before a strange combination happens, and it's probably going to be something that we missed. So I was really worried about this. And the consequences, well, the consequences would be something like a customer nobody can get into their office. It might be a car manufacturing plant or something like that. And can you imagine what it costs and how angry people will be if the people can't get into work? It would be pretty terrible. So, of course, I went out and recruited a student. that's how we solve a lot of things at Axis, and that's Edward here, who's going to be talk later. He actually is going to talk about his master thesis. We do a lot of master theses at Axis, and sometimes we just hire them on the summer to do this kind of work. And we usually try to hire some engineering students because they're so lazy that it's no way that that person is going to do this manually. There is no technical person that's going to do this by hand like this. 1, 2, 3, 4. I'm not going to count to all the 500,000, but you get the point. That's probably not going to happen. So I wrote a proposal for a master thesis looking into this, and I really wanted to do something called high-volume automated testing. There was actually an inspiration for this as well that comes from a professor in the US, which is quite famous with the testing community, called Cam Kainer. Famous in testing is, yeah, not really true. You don't get famous. Anybody heard of him ever? 3 persons, okay, 4, yeah. Anyway, this guy is a professor in some university in Florida, I think, and he had been working in testing in the 80s and doing a phone system. So phone system was cool in the 80s. And they had all these different combinations of what could possibly happen. People are calling and hanging up and putting on hold and all this kind of stuff. And they had done this thing of this is the flow of what's going to happen. And they had this flow, and they tested all these different flows that they had, but they didn't test all the combinations. And then the project is finished, and there's these customers that buy these kind of systems, like phone systems. And it's the same thing there. If the phone system stops working, you're probably going to be in a very bad situation. If it's a support or you're selling through the phone or whatever, it's going to cost you a lot of money if the system is down. And that's exactly what happened for him. The system went down. And the system went down because they missed something that in hindsight, and it's always hindsight, it was so obvious. They missed the fact that when people are put on hold in the queue, a lot of them are going to hang up. It's really obvious in hindsight. Like every bug you find obvious in hindsight. I don't understand why all these developers always do these bugs. The problem is it's only obvious in hindsight because you stumble upon one of these stars in this galaxy of possibilities, and it becomes really obvious when you stumble upon that. Why haven't you tested this? Haven't you tested everything? No, in fact, we didn't test everything. But I was determined to try to avoid the mistake that Cam Kainer had done in the 80s, and he had written a lot about, he's one of the founders of the exploratory testing ideas together with James Bach. And he has also been looking into high-volume automated testing, which is not a new thing. It's something that's been done for many, many years, but it hasn't been written about that much. So what high-volume automated testing really is, as the definition, this is the alarm. Don't worry, I think I still have a few minutes left. Now it's just, yeah, don't worry about it. So the definition from Cam Kainer is roughly that you automatically generate a lot of tests from simple algorithms. So it's not that you write a lot of test cases by hand and then you run them all. It's rather that you have some simple rule to generate a huge amount of tests. It's a high volume. Okay. And then you will also have some sort of simple oracle to know if it's a pass or fail. And then you have some automatic verification as well. So by relatively simple means, by simple programming, you can generate a huge amount of something. And there is a lot of different categories of high-volume automated testing. One example, which is probably the most famous one, is fuzzing. Have people heard about fuzzing? About health? It's very popular within security testing, where you just randomly put requests to a service, like you could have your bank's web server or something, and you just randomly generate a lot of requests, And then you know, for example, the automatic verification is just that I don't have the password for anything, so I shouldn't get access to anything. And the automatic generation in fuzzing is usually just random. You just have a list of API calls or something like that, and then just randomly put all kind of different stuff in there, and then you just do this fuzzing for a long, long time. And this is how Heartbleed was discovered, for example. They did something they weren't supposed to do. And this is also what hackers actually use sometimes as well. So I wanted to do something like this, and I had some ideas, but of course I was not interested in the fuzzing part. I was interested in testing 100,000 sequences. And so I got some student from LTH, the Technical University in Lund, that was interested, and he was going to do these three things. He was going to generate the sequences, which shouldn't be that hard, and it's actually quite simple. I will explain that in a minute. Then he was going to optimize, and this is pretty cool. I'm not sure it's that practical, but it's more cool than practical, and it was absolutely necessary to have the necessary academic difficulty of the master thesis, because the master thesis always has some professor at the university that wants you to do something cool. But it's quite interesting as well. And then he was going to automate the execution as well. So this was basically his master thesis, and it was either this or just doing it by hand. So he was very keen on doing this instead. Okay, so first of all, generating sequences. I talked about it before. You have some sequence like this, and then some sequence like this, and you just have an algorithm that goes through all the different combinations. It's not very hard to write an algorithm to generate all the 100,000 different sequences that you need. It's pretty simple. And then you just put them one after another, and you have a 500,000 long text file with symbols like letters, for example, which are representing some sort of action. So this was really, really simple and easy, and anybody could do this. But how to optimize? Because it seems like this is going to be really, really long. And when you start to think about it, from some point of view, it seems quite unnecessary to do it like this. Like you have these 5 A's in a row, and then you have the 4 A's in a row before the B. So there is a famous, well, famous as you can be famous as a mathematical concept. That's not very easy. But there is a well-known mathematical problem called shortest common superstring. Is there anybody that's heard about this? Ooh, awesome! You're the first person ever I've heard about, met that has heard about this problem. It's really common in genetics and stuff like this. They do a lot of work on this. I really have to talk to you during the break how you knew this. It's probably an interesting story. Anyway, you have the shortest common superstring thing is you have a huge string. Okay, here we just have these. Of course, you can imagine that then it continues on for 499,900 something letters. But you have something like this, and then you can have algorithms to try to generate a string that contains all these strings. So this is the superstring for these strings. So what the superstring means is that it contains all the other ones. So here is the first one, and here is the second one, and the third one, and the fourth one, and the fifth one. So this one contains all of that. So it's a bit like when you are compressing something. We do this at Access a lot in our video cameras, that you take the video and then you have some algorithms to encode the video so it gets smaller. So it's a similar concept, that you have all the information but in a shorter format. So this is extremely interesting for only one person here, so I won't go into any detail. but there is a master thesis on it if you would be interested in all the mathematical things. It took, he implemented some algorithms to try to generate, and it took about a week to generate the string. So on his computer at home, he made the program and then start, and then 1 week later he got the result of just generating the superstring. But of course you can reuse a superstring how many times you want. So only have to do that once. You don't have to do that every time. Then we wanted to automate the execution. So I mentioned before that, so this is the door controller. So there's like a Linux server computer in here connected to the network. And all these you have different kind of wires that you connect to the lock, etc. So the card reader, for example, and then you have the cards to swipe the card. You have the lock that's connected here, and you probably have some sort of door sensor. Anybody familiar with, you keep the door open for long for the office and it starts beep. As this thing starts to beep because the lock is open. This one knows that it's open. It tells this one to beep, etc. Yeah, and you sometimes have like this button. You can press the button to get out. Just as a side note, the most amazing thing that people thought about this thing when it came out, just to give you a hint of the state of technology in this market, it was color coding, because all through the last 50 years of the history of door controllers, they only have green, and it's a nightmare for the installer to know which. And because we didn't know anything about door controllers, and we didn't either know where to put all the wires, and somebody said, this is terrible, why don't we color code them? Yeah, let's do that. And the market just went, woo, technology. So it's I'm sorry if there's somebody here from the door controller market, but it's pretty lame. Until we came along. Anyway, you want to test all these things, and if I want to swipe my card here 500,000 times or something, I don't want to do this manually. How do you think that the companies that do this kind of stuff test 1 million? They don't test 1 million, but how do they test many swiping of the cards? Anybody want to guess? Sorry? Manually? That's a good guess, but they have technology for this. Yes, some kind of robot, good guess. They have like a robotic arm that goes around like this. Bleep, bleep, bleep. Okay, we decided to do something slightly more practical, because this is not very practical if you want to first swipe a card and then open the door, and you're going to have this robot army swiping cards and doing the pin card. It sounds completely crazy. And we looked everywhere. I talked to people in some of our competitors because we're doing standardization. They have no standardizations on the APIs or anything, so we're trying to do standardization with these guys, and I'm asking and talking to them, and they know, no, you can't test everything. So why bother? You can't test everything anyway. So what we wanted to do was replace all of this stuff with an Arduino microcontroller. How many are familiar with the Arduino microcontrollers? About half. Okay, so it's a simple computerish thingy. It's not like Raspberry Pi, which can run a full Linux OS on it, but just a microcontroller that you can program and do some cool stuff at home. Like you could put something like a light sensor on it, and then connect your lamps to it, and ta-da, you can control your lights at home. Of course, you can just buy this kind of stuff, but for do-it-your-own kind of people, they want to do it themselves. And it's an open source hardware, which is quite interesting. This summer, it forked. It's the first open source hardware project that forked. It's because people got pissed at each other. It's the main reason why anything forks in the open source community. And it has these wonderful things because Access wants to connect everything to a network. We don't want to interact with anything if it doesn't have an API. So it's also possible to buy these kind of Arduino network shields, they're called. So you connect this to the microcontroller, and then you can control it with network API calls. Okay, so by the way, if you're interested in Arduino and door controller stuff. We put this all open source on GitHub, and amazingly enough, almost none of our competitors showed any interest because they already had the robot arm. Blip, blip, didn't see the point. So what it makes possible, okay, so you saw the color-coded stuff. These are like many door controllers, so this might symbolize an office. And here is the microcontroller, the Arduino, connected to all these, so we don't have to have the swiping of the cards or anything. And this one is connected to the network, and then I can sit on my computer, and I can either click in a web user interface kind of thing, or I can just send API calls. So it's swipe card, open door, yada yada, and it sends it to this, and the door controller doesn't know if it's connected to a microcontroller or real lock or anything, because this simulates the whole thing. So now we have this automated, and now all of these different kind of API calls is going to be represented by all these A's and the B's and the C's, etc. So now it's just a question of having a script that sends all these 500,000, but now we've compressed it to about 100,000 different API calls. And of course, we just do it on a big scale. We just a lot of stuff, and now we're just brute forcing it. So it's a bit like two different kinds of testing. Either you try to figure out in an intelligent way which parts to test, or you just try to brute force it. So imagine you're a hacker. You might either try to guess somebody's password, or you might just try 500,000 of the most common ones. So we just brute forced this, attacked it with all the different kind of things, and it took about a week to run or something like that. And how did it go? Want to guess how many bugs we found? One bug. Found one bug. But it was an important bug. It's a very interesting bug. Most of all, we also knew that we have tested now a lot of combinations, and I could sleep better at night releasing it out into the world. So it gave us confidence to ship this thing and know that we could look the CEO in the eye and say, we've really tested this well. We believe this will not harm the brand of Axis. Don't worry about it. It also gave us the tools to test much more stuff, because now we had all this stuff that we were forced to implement because we wanted to test everything. So we didn't just do the robotic arm thing. We were forced to do something more intelligent, and it broke the illusion of these project constraints. You can't test everything. Aha, but I have. Well, of course, not every possible combinations of everything, but I tested a lot. So what did we learn through this experience? First of all, that high-volume testing can be a very powerful tool. It's not the solution to testing. It's not going to replace all other kinds of testing, but it's a really interesting and powerful tool if you spend some time trying to figure out all the things that you're expecting people to do and the mistakes people might do, and then, well, and just to be safe, let's test these 500,000 things as well. It's also interesting because we found this bug. It was maybe easier to test just all the combination, but instead of just trying to guess everything that you need to do to test. This is not true in every case, but in some cases, especially when we're doing something like in this door controller thing, we were doing something that we were not very familiar with. So it was very hard to guess which combinations to test. Then it's maybe easier to do this. On the camera side, where we've been doing testing for 20 years, it's not probably, we've looked at it a little bit, it doesn't give us as much information because we're really, really good at this. We are still learning about this. We're still trying to implement, we're still trying to figure out how the best uses are.